So there are a couple of just really big issues. Hallucination, these models make things up with very high confidence. Attribution, we don't know why they're saying what they're saying. We can't really trace it back to anything. There's compliance issues, so we can't really remove information from them, which is kind of tricky from a GDPR perspective, for example. We can't revise information. We can't keep it up to date. There's massive data privacy issues where you have to send your very valuable company data. If you're an enterprise, you have to send that to somebody else's servers.
Douwe, I am excited for this. Listen, we've chatted before, we've known each other for a while, but thank you so much for joining me today.
Yeah, thanks very much for having me on the show. I'm a big fan.
Oh, it's very, very kind of you. I literally paid you $25,000 to say that. But but my question to you is, it's such a hot space, and there's very few people who've actually been in it for a while. You are one of them. How did you first make your way into the world of ML and NLP first?
Yeah, my journey has been a little bit unusual, actually. So when I was in high school in the Netherlands, I wanted to be a cool kid during the day, but at night I was secretly fascinated by computers. So I started off as a script kiddie, wanting to hack other people's computers, and I figured out that if I really wanted to do that, I had to learn to code. So I taught myself to code. Figured I needed to understand operating systems, so I made my own operating system with bootloader and everything when I was 16. So then by the time I had to go to college and go study something, I thought I already knew everything about computer science. So I decided to study philosophy instead. So that was really a very radical departure from what I had been interested in at the time. But it was fascinating learning a lot about the mind and language and things like that. I use it still every day, I think. But then at some point in my career, it became clear that I had to start making money. So I needed a real job, and philosophy is not really a real job. And I did some logic in between foundations of math, which is also not really a real job. So I decided to study computer science after all. So I went to Cambridge in the UK. I had a fantastic time there. And so that's really where I started doing NLP, natural language processing. And one of my internships was done at Microsoft Research in New York with a very famous researcher called Léon Bottou, who is Yann LeCun's kind of, I wouldn't say sidekick, because that doesn't really do justice to what he's done. He's invented like stochastic gradient descent and things like that. So one of the godfathers of deep learning. And I had the opportunity to work with him. That was really an amazing time. So afterwards, when Yann and Leon started FAIR, Facebook AI Research, I joined that out of my PhD, and that really kicked off my career.
I actually spoke to Leon as part of the prep for my interview with Yann. Amazing, amazing person. But I do want to talk about that 5 years that you spent at kind of Facebook's AI research team. It's such a transformational team, as you said, with incredible individuals like Yann and Leon. What are your biggest takeaways from that experience, and how did it impact how you think today?
It's really a one-of-a-kind place, especially when I just joined. They had these amazing people who I really respected a ton, like Jason Weston and Thomas Mikolov, really kind of the godfathers of modern deep learning for NLP. I learned so much there, mostly around how to focus your research direction. So I think initially I was doing all kinds of weird stuff. And it took me a while to figure out that having a very clear real-world application for the research that you're doing makes it much more valuable than going off on a tangent and maybe being a bit too far ahead of the rest of the field. It's really a special place, and I think actually they don't get enough credit for the impact that they've had on the world. So, and I mean like Facebook or Meta in general, actually. So. Almost every web app in the world runs on React, which is an open source project coming out of Meta. Almost every deep learning project.
Can I interrupt you and ask, like, bluntly, I agree with you. Do you think they've captured that value, though? Because so much of the value that they've created seems to not be inherent within the company. I would argue from a pure economist standpoint, it isn't enshrined in the company, and actually it's been too open source.
If from the perspective of making money, maybe, but from the perspective of doing something for the world. So I think Facebook and Meta's mission is to connect the world. And so through things like React and PyTorch, maybe they're getting closer to that mission without making more money because they're already making enough money anyway. I don't know. But so PyTorch really, without PyTorch, none of this stuff would be happening right now. Right? So it's really like fundamental for all of the AI breakthroughs.
It's a wonder why I'm such a natural venture capitalist when I have a proclivity for making money. But you then spend time at Hugging Face, okay? And so with that transition, again, one of the most prominent kind of rising stars in the space, how did that impact your mindset today?
Yeah, Hugging Face is really a fascinating company. And so I was at Meta. I was looking for something new. I was thinking about maybe doing a startup already. And then figured I needed to get some more experience first at a successful AI startup, and Hugging Face very clearly is a very successful AI startup, and it also really aligns with some of my values around open source and open science and things like that. And they have amazing people like Meg Mitchell working there. So I went there, and I think what really impressed me actually is how good they are just at marketing and branding and community building. It's like everybody just loves the company. And I don't understand how they do that. So it's really, something to see. Even when you're on the inside, it's like, wow, like, look how popular we are.
I thought it was amazing. I actually spoke to Clem, and in my research, they said about doing swag, where you could essentially pay to have whatever swag you wanted. It just had to have a Hugging Face logo on it. And so everyone gets a budget, and you could buy, I don't know, I'm making it up, maybe a Balenciaga hoodie, probably not given the price, but put a Hugging Face. And so it makes it much more personalized, real, cool. I thought it was really interesting, actually. Just kind of, I've never heard that before. Okay, so we have Hugging Face and experience. Where does Contextual come from? What was that aha, I've got to do this. This is now the idea and the time.
Yeah, so this really started at the beginning of the year. So me and my co-founder, Amanpreet Singh, who I worked with first at Facebook and then at Hugging Face. And he really is one of the smartest people I know. He's really an incredible guy. And we were talking about what to do next. And we just saw this great need after ChatGPT had gone viral. We saw this kind of great excitement in the world, but at the same time, a lot of disappointment about it not being quite ready yet for real world adoption in enterprises where you actually want to use this technology. So we decided that now really is the right time to build a company to try to tackle that. And we think it's still very early innings in the game. So I think a lot of people sometimes think that it's, the game has been played, but it's just getting started.
It's a Friday afternoon. We're going to have a fun chat. Fuck the normal stuff. Okay, so you said there about not being ready for like traditional adoption. Mm-hmm. I think a lot of the general public would say absolutely it's cool. What makes it not ready for general adoption, do you think?
Yeah, so there are a couple of just really big issues. Hallucination is a very big one. These models make things up with very high confidence. Attribution, we don't know why they're saying what they're saying. We can't really trace it back to anything. There's compliance issues, so we can't really remove information from them, which is kind of tricky from a GDPR perspective, for example. We can't revise information. We can't keep it up to date. There's massive data privacy issues where you have to send your very valuable company data. If you're an enterprise, you have to send that to somebody else's servers. These models are also quite inefficient still, so you can make them much faster. And so what we are building at Contextual is a different kind of language model. So we're really thinking about this as the next generation of language models, where we think about it from first principles for enterprise use cases. And what that means is that we want to solve all of these problems by being a bit smarter about the architecture. And the architecture we're specifically basing it on is Retrieval Augmented Generation, which is something that me and my colleagues at FAIR came up with in 2020. And what you do there is you decouple the memory from the generative capacity of the large language model. And this allows you to ground the generations from the language model in the things you retrieved in your memory, essentially. So you get much less hallucination, you get attribution for free, you can always update the memory, so you can remove information on the fly, you can add things, you can revise them, you can have a stream of memory. It's much more efficient because you're compressing a lot of the compute inside the memory. and you have a very clean separation between the data plane and the model plane, as they call it, which means that you can have better data privacy guarantees.
I mean, I have so many questions for you. I literally have like this wonderful like scrap of paper where I'm writing notes. First off, you said there about kind of attribution and knowing where it comes from and being a bit of a black box. I had someone on the show the other day, and they said, open or closed, you still don't really know what's going on in the core foundational model layer. The open or closed is not really the point. You still don't know. Is that true? And how do we think about actual true transparency of knowing what's going on and why it's producing what it is?
Yeah, so we're not going to be able to really know why a neural net does what it does at the scale that neural networks operate at. So this is kind of like your own brain, right? Like, so I think your behavior is relatively predictable. So that goes for every human, right? We all can predict each other's actions, but I have no idea what's going on in your brain, and I will never know. There's no way I can know. The only way I can kind of find out is by asking you. But if you train the architecture the way we are training it right now, then at least you make sure that the model has learned to rely on the information that it finds. And that gives you much stronger attribution than if it's just predicting the next word based on what it has seen before, because it doesn't have this ability from birth, basically, to find relevant information and ground its generation on that thing it found.
Another thing that I have to ask, you mentioned the word hallucinations there. I had Emad at Stability on the show, and he said hallucinations are a feature, not a bug, which I thought was a very tweetable statement.
Yeah,
but I didn't quite understand it. Do you agree hallucinations are a feature, not a bug? He is the only person to have said this on the show, to be clear.
So I think it's a great quote, but as always, it's a bit more nuanced than that, right? So I think in some cases it is a feature. If you want to use a language model for creative writing, and if you want it to be really, really creative, then you probably want it to hallucinate. So in a way, it's a spectrum of groundedness and hallucination, where if you really care about the language model doing the right thing and you want to deploy it in an enterprise critical situation, then you really don't want it to be creative, you don't want it to hallucinate, you just want it to do what it has to do. But if you want to use it for a creative writing exercise, then sure, you can have it hallucinate, because you're going to revise whatever it gives you anyway.
Totally agree with you there. You also mentioned kind of the multi-model aspect. Another guest on the show said that the winners in startup land will be determined by those who can bluntly switch models faster than anyone else, and that today's models will be unusable in a year. Do you agree with them?
At this particular point in time, probably yes, but just because the field is moving so incredibly quickly. And so I think that in the next year, we're going to see lots of other models coming out. And if you can have a language model agnostic AI company that relies on language models, then that would give you a competitive advantage. But at the same time, that also runs the risk of you relying on other people's language models. Yeah, it's a bit of a tricky situation.
Do you think there will be many more startup language model companies? Like when we look at what we have today, there are kind of the core incumbents, and I would probably include even I would definitely include your OpenAIs, but even your kind of Anthropics of the world in there. But like startup, do you think we already have our incumbent model companies set and fully baked?
Well, I don't think so. Otherwise, I wouldn't have started this new company. I think this technology is really going to change the world and every aspect of it, which means that it's a giant market and there's a lot of room for lots of companies to do innovative things. So there are definitely a couple of incumbents, but they are also focused on very specific parts of the market. So if you look at Anthropic and OpenAI, I think they're really chasing for this idea of AGI, and they're relatively consumer facing. And if you focus less on this idea of artificial general intelligence, and you want to have something a bit more like artificial specialized intelligence, where you just need the model to do what it needs to do. You don't need it to know about Shakespeare or quantum mechanics or things like that. You just need it to solve your business's problem. In that case, I think there's still a lot of room for innovation, and that's where we are trying to innovate.
How does the speed to get there change when comparing artificial general versus artificial specialized intelligence? Is it actually the same timelines, do you think, or is there a variation?
Are you asking if we'll achieve AGI at the same time as ASI?
I'm saying, given the closed nature of like tasks available, if you think about AGI, it's an infinite pool of options. And if you look at ASI, if you would take certain roles or functions, there are finite outcome scenario plans that could happen, in which case it would be quicker to get to higher quality ASI than AGI. Is that correct?
Yeah, that's right. So AGI, I think, so it's slightly better defined now, but one of the big issues has always been that we don't really know what that term even means. And so ASI, so that basically just means the kind of old school applications of NLP, but then done better with better models. And I think you're totally right that that's a much easier problem to solve much quicker and then slowly grow with the capabilities of these models.
In terms of like growing with the capabilities of the models, we've seen size of model matter less and less, it would seem. How do you think about the importance of size of model today? And does it matter as much as it used to? And will it matter even less with every year, month, day?
Yeah, great question. I think Sam Altman had this interesting quote where he was saying that he thought models would stop growing in size. So that GPT-4 kind of hit this ceiling. And I think that's probably right, but not really because size doesn't matter. It's just that data size matters even more than model size. And I think the Llama paper out of Meta really brilliantly showed this. Where if you train a smaller model on more data for longer, then you get a better model. So you get more bang for your buck if you train it on more data rather than having more parameters. But in an ideal world, if you had infinite compute budget and infinite data, then you would train the biggest possible model because that's the most likely to give you sort of emergent capabilities, as we call them in the field.
Sorry, I'm really stupid, so forgive me for this. Does that take more time then? If you have smaller models with more data, given you need to feed more data through the model, does it not take more time than if you needed less data going through the model?
It depends. So it's a trade-off, you're right. But these big models also need a lot of data. So it really is a function of the number of GPUs that you have available. Right? And so if let's say you have 1,000 GPUs, you can choose to train a huge model on relatively little data, and it will be okay, but it will be undertrained. So you have some sort of optimal point where you can train the model to perfection. And I think in the field, we were underestimating where that optimal point is. And it seems that data is much more important than model size when it comes to what's optimal.
Okay, if we take this to a next, like a layer deeper, data more important than model size. What does that mean then in terms of who's advantaged? Does that mean that startups are more advantaged actually than incumbents because they don't need to I don't understand who's more advantaged in that case. Is it incumbents because they already have existing massive data moats?
It depends on where the data comes from. I think incumbents definitely have an advantage there, but only some of them. A lot of the data is just freely available on the internet. Right? So the Llama model was not trained on any proprietary data. It was just trained on open data on the web. And there's a lot more data to be had there. And as a society, we're generating a ton of data every day to add to that big pile of data. So you can really train very high quality language models just on public data on the web. But I think if you look at the secret sauce to a lot of these other models, like why is GPT-4 so awesome? A part of that is that they went through enormous lengths to get like special data that nobody else has. So allegedly they did this Whisper project where they're very good at transcribing audio because that would allow them to transcribe like all of the podcasts in the world, which gives you very high quality language. So if you can train on that language, but nobody else has it, that puts you in a position of advantage.
I really hope no one's training on my podcast. I feel sorry for those models, but I would love to. You mentioned kind of the proprietary data element there. How important is proprietary data? I'm a VC. for my sins. The main reason I would say why VCs are turning down startup AI companies is because they do not have a proprietary data set to operate against, and they are defined as like a thin layer of generative AI on top of a foundational model. How important is proprietary data, do you think, for startups innovating in the space?
It really depends on the specific startup. So if you want to build a deep tech AI startup, then you really want to get a big data flywheel going. So you want to start with a lot of data and then have a way to generate lots more data, and that data is going to be your moat. But I think one of the interesting things about these large language models is that they're incredibly sample efficient or data efficient. So you can do cool things with them with relatively little data. That just previously just wasn't possible. So that unlocks all kinds of possibilities that just didn't exist even a couple of years ago. So on the one hand, yes, you need lots of data if you want to build like big AI first things. But at the same time, if you want to do a startup that builds on top of this technology, you need very little data to get started. And actually, one interesting, maybe a little bit of a tangent, but one of the use cases I've been seeing now for GPT-4 is actually that people are using it to generate data, and then they're training on that data with cheaper models. And so GPT-4 might end up disrupting not like knowledge workers necessarily, but it might just disrupt like Mechanical Turk and is just an annotator on steroids. And you can use all of that data to get much more custom models that you can then deploy very cheaply on specialized use cases. So that's a quite interesting development.
Can I ask, in terms of like the proprietary data element, pre-trained data changes a lot. Can you just help anyone who doesn't know understand what is pre-trained data and how does it change the game for a lot of companies that don't have existing data moats?
Yeah, so I think maybe it's useful to kind of go through the steps if you want to build your own chat GPT. Like, what do you need? And so the first thing you need is a core pre-trained model. And this tends to be just trained on the web. The task you're training it on is just next word prediction. Then once you have that core model, then you want to do supervised fine tuning. So essentially you want to fix the user interface to that model because the model doesn't really know how to follow instructions, for example. So you want the model to listen to you, but it has only been trained on predicting the next word. So it doesn't really know how to do that. So that supervised fine tuning, that's also proprietary data if you want. You can get a much better model out of that. And then the final step is RLHF, reinforcement learning from human feedback, where you get this feedback loop to make the model even better for your specific use case, even if you don't have signal at the word level, you just have signal at the sequence level. So you can tell it like, okay, that was a good response or that wasn't a good response, but you can't tell it like, what did you do wrong necessarily? So if you go through those three steps, then you get a ChatGPT. It's as easy as that. But obviously there's the devil's in the details.
Can I ask you, which company do you think has the best data acquisition flywheel? When you look at them today, who do you admire and respect most?
OpenAI. So maybe that's not the answer you expected, but so it's just an incredible company, and they've really shown the world what's possible. And they haven't even really trained, as far as I know, on the data that comes out of ChatGPT going viral. Right? So they had ChatGPT, it went viral. This led to this giant data moat that they haven't even really used yet. So I think in terms of data moats, and maybe you've seen this come by, actually, there was this Google memo from an internal Google employee who had written that OpenAI and Google have no moat. I think for me as an AI researcher, when I read that memo, I was like, this person has no idea what they're talking about.
Unpack that for me. Why are they wrong and don't understand?
So these places have a giant moat because, as I said, it's really all about data. And OpenAI has this very deep understanding of how people want to use language models that basically nobody else has. And they have this giant economy of scale where they can serve up language models very, very cheaply because they get so many requests coming in at the same time. So they have a giant moat. And as much as so I'm a big fan of open source, right? I would like it to be true that with open source we could just keep up with all of that, but I think that's just incredibly naive.
Okay, so they do actually have the moats. What do you think are the biggest challenges that they face? Because I think we all dismissed Google quite significantly, if I'm honest. And then Bard came out and was pretty impressive. Like, how do you evaluate Bard and Google's display, actually?
Yeah, language model evaluation is a whole separate topic. It's a super interesting question. Actually, I've been fascinated by AI evaluation for a really long time, and the answer is we don't really know how to evaluate the quality of these models anymore. So what we've seen people do in the field now is they're using GPT-4 to evaluate the quality of other language models. And that just feels wrong. So I think there's a giant opportunity in the market actually for a startup or several startups becoming like the Moody's or the S&P, the folks who evaluate the quality of AI for specific use cases, because nobody really knows. It's really the Wild West out there. And one of the big problems, for example, is data contamination, where a bunch of these language models are trained on the things that they are being evaluated on. So GPT-4 looks like it's an amazing coder, but it might also just be trained on the data that it's evaluated on, which means that it's not actually that great of a coder.
Okay, sorry, I think this is like fascinating. And when you think about kind of the Moody's and the S&P opportunity here, the question is though that I still don't quite understand. How do we know a yardstick for progress or measurement? What is the right way to approach AI measurement and effectiveness?
Yeah, so the standard way to do it, and there are great benchmarks for this, right? So there's the Stanford Helm project, the holistic evaluation of language models. And there's a long tradition in NLP around like glue and super glue and these benchmarks where you look on static test sets, how good language models or any other kind of NLP model, how good they are on this static test set that's held out. But I've been arguing for a long time that that's just completely wrong anyway, and we need to do something that's much more dynamic. So I've been involved in this Dynabench project, dynabench.org, and the idea there is that you cannot really have a static test set because people can just overfit on that test set. It doesn't really give you the full signal you want. So ideally what you want is to see how easy is it for an adversarial person to mess with your model. And the harder that is, the better your model is. And so it used to be very easy to come up with adversarial attacks where these models would just completely mess up. And it's getting harder and harder over time. So that sort of success rate of an adversarial attacker, that's something that you can keep evaluating over time. So we need humans to evaluate these models by trying to break them.
Sorry, I'm going off on a tangent. I'm too interested. When you say about kind of the adversarial entrance and abilities, does this mean we'll have like an entirely next generation wave of cybersecurity companies around model protection?
Oh, absolutely. Yeah. That's completely going to change everything. So these models can also get contaminated with data itself, right? So we need the security layer on the generations of the models. You can do all kinds of prompt injection attacks. These models, right now, they're still mostly just producing language, right? But they're starting to produce code and instructions and actions. And when that happens, then you can mess with the model to get it to produce actions that you really don't want it to produce, like removing your entire database and things like that. So that definitely is something that you want to think about.
That'd be a bad morning, wouldn't it?
Yeah.
Okay, my question there is, okay, but is that built by Contextual? Is that built by OpenAI in terms of a data contamination checker, in terms of a health checker? Or is that a next generation Symantec, you name it, security company, external that you provision internally?
Yeah, I think there are lots of startups looking at this opportunity. So I guess standard security companies are also looking at this right now. So it's very obviously a very big new threat surface. And so that's an interesting part of the market. But I don't think that the actual foundation model builders like OpenAI and Contextual are going to build that technology in-house. It's probably going to be an external sort of audit
How much of a concern is data contamination at this stage, do you think? If you're sitting in OpenAI today, how do you think they discuss data contamination?
I think they're aware of it. I think they're starting to invest more in evaluation, which is a good thing. They probably should have done that sooner. So yeah, they have an army of annotators now, human annotators who are checking their models. So they probably have a pretty good sense of how good their model actually is. But obviously, they're not going to share that with the world.
I have to ask, I had Yann LeCun on the show, who we discussed earlier. Obviously, a very big proponent of kind of open models. It's kind of a very big debate, obviously, between open versus closed. Where do you sit in terms of the model that rules for the next 5 to 10 years? And is it different for the model that rules for the next 5 years versus that rules for the next 10?
So the way I think about the language model space is kind of as a pyramid. So at the top of the pyramid, we have these frontier models. So these are GPT-4 and Anthropic models and things like that, that are just much better than everything else, but also much more expensive and much bigger than everything else. And then at the bottom of the pyramid, you have open source models. Anybody can train on them. Anybody can fine tune them on their data. You can run them on your phone now and on your laptop and things like that. So that's a very fruitful area for research. But I think the most interesting part is kind of the middle piece of that pyramid, where you have the most bang for your buck. So that's, from a business perspective, the most interesting part, where you have mid-sized models that have capabilities that you don't really see at this bottom of the pyramid, that you can monetize it in various ways. So I think it's not going to be the case that there's just one model that wins everything. It's going to be lots of models at different parts, different layers of this pyramid being used for different kinds of applications. So if you have very strong AGI requirements, you probably want to have a frontier model. If you care about it a bit less, maybe you want to have artificial specialized intelligence. If you care about it even less, then you can just take an off-the-shelf open source model. So there is always going to be a place for open source. But why I don't think that open source models will move up that pyramid to the frontier is because they're just too expensive. And this whole flourishing that you see right now of open source models, that basically comes from Meta's generosity in giving Llama away for free. And if they hadn't done that, then you wouldn't see that.
Can you just help me understand, why are they so much more expensive?
So they're just bigger models. And if you have to train a bigger model, then you need more GPUs, and GPUs are expensive.
You're like, God, Harry, this is like teaching a 2-year-old. As I told you, I'm like the only VC that's like not afraid to ask the most dumb questions.
That's a very good question.
Honestly, it's a really good skill to have, by the way. But so we mentioned there kind of the 5 years and the 10 years out. We saw Elon's petition. EMAD at Stability very much was in favor of it on the show. Where do you sit in terms of Elon's petition, and how did you read it?
So this is the petition where he asks everybody to stop working on AI so that he can catch up, right?
Yeah, for 6 months.
Yeah. So I think a lot of the narrative in the media right now is really driven by self-interest from a bunch of folks in the field. So the whole kind of existential risk debate, I think it actually comes from a very good place, and a lot of people are worried about this. And I think there is a non-zero probability of AI extinction risk. So it's something we need to think about, and a lot of smart people are thinking about this, like Benjo and Hinton and all of these folks.
What makes you say there's a non-zero chance, Douwe?
Well, so there is just a non-zero, but very, very, very small chance that there will be some sort of paperclip maximizer scenario. Have you heard of this paperclip maximizer?
No, tell me more.
So if you give a very intelligent system an instruction like you need to make as many paperclips as possible, then it's going to turn everything into paperclips. And it's going to basically destroy the planet and turn everything into paperclips, because that's its objective function. So in the process of maximizing paperclips, it will destroy everything else and turn the whole universe into paperclips. So I mean, you can see why I'm saying that these are very, very small probabilities, right? So probably the chance of me getting hit by lightning like right now is much higher than that happening. So I think one of the issues I have with the whole debate around existential risk is that it's really a tiny probability, but we're pretending like it's a massive issue. And I think there are much bigger risks, right? Like nuclear war and pandemics and climate change. And those are things we should be focusing on much more. So the people who are pushing this narrative are really the people who are benefiting from this being the narrative. So these are the incumbent AI companies who want to have either the market regulated, right? Because then they benefit because they can deal with the regulation, but small companies like mine can't. Or they are the folks who benefit from kind of fear mongering in the broader public, where people start having a lot of respect for AI's capabilities and want to use it everywhere because AI is so smart it might even kill us all. So I think there's a lot of kind of dubious motives behind the scene there.
Can I ask you bluntly, are there 1 to 2 fearmongers who you think are the most excessive?
Are you asking me to name names?
Yeah.
I don't think I can single out like one individual. I think so. There's a whole movement around this, and a lot of it is really motivated by just like smart people wanting to do something that matters. So my good friend Kyung-Yeon Cho did this nice interview the other day where he was worried about hero scientist narratives, where a lot of people in AI just like to feel special and like we're sort of like saving the world by doing good research. And so I kind of like that narrative, but it feels a little bit naive.
I absolutely love that. No, I totally get you. You mentioned regulation there. I think a big question for me is like, I don't think the chasm has ever been greater between private, like company knowledge, especially around kind of AI, well, specifically around AI, and then also the regulators' knowledge, which is significantly behind. How can effective regulation be set with such a large chasm between private sector knowledge and regulator knowledge?
Yeah, we have to invest a lot in educating regulators. And I think the AI community has been terrible at this. And I think the broader populace just needs to understand much better what AI is and what it can do and what it can't do. And I think it's been slightly self-interest driven, I think, in that a lot of folks in AI have just wanted to keep the technology for themselves. And that's why they haven't really invested in educating the rest of society. So I think that's really a huge issue. And so there's a bit of a side point there, but I think the people who tend to write the regulation, they generally don't really understand technology all that much anyway. So if you look at like the Senate hearings with Zuck, where these senators were asking him questions about the social network algorithm or whatever, and they didn't know what an algorithm was. Like, so that's
didn't you love it? Like, how do you make money? Adverts. Huh. Okay. That was brilliant.
Yeah.
So good.
So
as two Europeans there, you're watching this like judicial system and it on its knees, like, guys, for Christ's sake, you are so fucked.
Yeah. So I think this will come with time. I think the main risk, and so speaking of Europeans, what Europe is going to try to do is overregulate everything and just completely destroy innovation. I'm very worried about that. I think the US is traditionally much better at not overregulating markets to let innovation thrive. And I hope it stays that way. I think nobody really benefits from overregulation here except the incumbents. And those are the big tech companies already lobbying for regulation anyway and spreading fears of AI existential risk and things like that.
So can you, a final one before we talk about B2B adoption, and then I promise I'll let you go. I'm quite concerned about the EU's regulatory stance around AI. I mean, what they've suggested so far pretty much makes it impossible for most startups to use any models that aren't owned and operated by themselves. How do you think about what happens with the EU regulation?
I'm really not an expert on that topic. There's a reason I live in the US. But the European Union just has a tendency of really killing innovation because they think they can lead through regulation. And that's really the only thing that they're really good at.
It's a very dangerous thing when everyone wants to be the leader, and the best way to be the leader is to be the first and the strongest and the hardest.
Yeah.
And when you apply that to regulation, it's like
it's even worse, right? Yeah.
Yeah.
If they keep going, there won't be anything to regulate because.
I mean, welcome to
nobody's
French labor. Douwe, if you were in France and you wanted to fire someone, I mean, good luck. It is easier to get divorced. But I want to talk about B2B adoption before we do a quick fire. Essentially, we had Emad on the show, as I said, and he said, hey, businesses aren't really adopting it yet. It's going to be a tidal wave of adoption next year. So I guess the first question is, what are the fundamental blockers for businesses adopting AI today?
So Emad is really great at speaking in quotes, by the way. That's another great quote. I think the tidal wave is coming. There are just big problems that we have to overcome, and these are the things I just talked about, right? So hallucination, attribution, compliance, up-to-dateness, data privacy, latency, and I think the whole field is moving in this direction of just making everything ready for enterprise usage. So this is going to happen.
Do you agree with Emad on the timing? Next year will be the year when enterprises adopt AI at scale, and it will be a freaking train, in his words.
I think it's already happening. I was at an exec event at Google earlier this week, and there were all of these C-level folks from all companies across the world, and they were all talking about how they're using AI, and everybody's experimenting with it, and it's starting to make it into production already in various places. So I don't think we have to wait for a year. It's already happening, but there are just some big hurdles that need to be overcome, and they will be overcome very quickly.
Do you think it will be a fast or a gradual adoption? I'm always aware that excitement is very quick, but actually, like any new technology cycle, it always takes a little bit longer than one thinks, actually.
Yeah, it will be gradual, I think, and a lot of work is right now actually going into finding the right use cases for this technology, because people are now starting to think that they can use GPT-4 for anything, and that's just not true, right? So I think people are trying to experiment with the right use cases for different types of models.
Can I ask you, I spoke to a big European company the other day, and they said the biggest challenge for us is, we're a bank, we have millions and millions of lines of kind of transaction data. There is no freaking way we are letting any of our transaction data go anywhere off-prem. Like, it has to be so secure, on-prem, it is our lifeblood. How do you think about security of large enterprise data and willingness for it to go into models like OpenAI without security loss?
Yeah, absolutely. That's really one of the big questions, right? And that's why what we're building has this very clean separation between the data plane and the model plane. Because then you have much more control over where the data goes.
What can you just talk us through that? What does that separation mean?
Yeah, so traditionally in cloud deployments, you talk about the data plane and the control plane. And so control really is, okay, you're a startup or a company and you want to be able to deploy models and things like that to your customers' VPC, virtual private cloud, but you don't want any of their data leaving their VPC. Because it's their data. So that's the separation between the data plane and the control plane. So in this new setting where we have language models, there's this model plane, and it's kind of unclear where to put it. So you could put the model inside the customer's VPC, and then you get full data privacy, basically, but you have no control over what that model is doing at all. And you get no feedback, you get no learning. So you want to find interesting hybrids where you can respect data privacy, keep the data plane inside the customer's VPC, but put the model somewhere else. So you can do that if you have a decoupling between the retrieval part and the generative part, which is what we are building.
Can I be a bit savage? When you look at all the VC fundraisers, do you go, oh my God, these guys have no idea what they're doing when they're investing in X startup or Y company. Do you look at it and go, this is getting crazy?
Not so much. I think some of the rounds were pretty big, but I think it's also justified just because this stuff is really going to change the world. Right? So one bet, if it's right, has massive payoff. So there's this narrative, I think, in the VC community that there are these crazy rounds happening, but I think they're happening for a good reason. So I haven't really seen any companies come by where I was like, wow, like why are they getting this much money? There's a few of them where I thought, okay, they really have to live up to massive expectations now, and they need to actually start making real revenue now. Because at some point there's going to be a disillusionment with the technology, and then funding might dry up, and then these places are really in trouble.
Can I ask you, when you look at the incumbent set, who do you think has the strongest strategy execution to date? Is it Facebook? Is it Google? Is it Microsoft? Is it Apple?
So I've been very impressed actually by how Microsoft has managed to turn everything around by strategically collaborating with a better AI lab in the shape of OpenAI. And they've just really turned that into this narrative where Microsoft is an AI leader again. And they really weren't an AI leader even a few years ago.
On the flip side, who do you think's not done well and not adjusted to the new landscape?
So I'm still very curious to see what Apple will do. I think they had this great vision of having like Siri on your phone and things like that. So that's like one of the first personal assistants. So if that could be a super powerful language model, then that could do very interesting things. But so far, I haven't really seen a lot of interesting things coming out of Apple.
I want to do a quick fire round. I've peppered you with questions anyway, but this is like a more structured peppering with 60 seconds per one. And so it's much more, informed, and the questions will actually be on schedule, unlike the rest of the, last 45 minutes. Does that sound okay?
Yeah, that sounds great.
So what do others not know that you know to be true?
So I think others are underestimating how early it still is. So AI, it feels like we've made so much progress that it's very hard to enter the market right now. And I think that is just not true. It's still very early innings. We haven't settled on a lot of things that need to be solved before we can really have this technology be ready. So it's still very early. And so me realizing that gives me a competitive advantage, hopefully.
What do you advise founders who are building AI companies not in the Valley? Do they need to be in the Valley?
No, absolutely not. I think the Valley is kind of a dangerous bubble in a way where there's this giant echo chamber happening. And I think if you look at a lot of great AI companies, they're not in the Valley and they don't have to be here. Maybe they should have an office here because there are great universities to recruit from and things like that. But I really don't see a reason why you would have to be here.
What would you most like to change about the AI community?
I think there's way too much hype. And I think it would be good if the community at least acknowledges that and tries to really pay attention to the things that matter, like having technology that actually works and not just jumping on the next hype train. And there's an auto GPT thing that is going to change the world, but doesn't actually work. And so there's a lot of debate right now that is just driven by Twitter and just kind of like sound bites and quotes like Ahmad, where I think it would be better to be a bit deeper and think a bit more carefully about what we're doing.
Some fantastic quotes, though, weren't they? I mean, credit. No, I'm with you totally. Okay, do you agree that some of the biggest businesses to be built in AI over the next few years will be services businesses for large enterprises helping with AI implementation?
Yeah, totally. So I don't know if those are going to be new businesses or existing incumbents. So the hyperscalers are also trying to play that role. But there's just so much demand right now for AI in any kind of enterprise, and it's still very hard to get it right. So a lot of these companies are just looking for help, and so yeah, there are just opportunities there.
You mentioned the philosophy degree earlier. How do AI and philosophy help each other in your day-to-day role?
Yeah, I'm very happy that I studied philosophy. So philosophy is really about conceptualizing anything and kind of any arbitrary level of abstraction, and that ability you can use anywhere. Right? So for AI in particular, I think that philosophy and AI are an interesting combination because philosophy is about the stuff that you can't really do science about yet. So at some point, the things that people are philosophizing about now, they become scientific questions that just have answers or hypotheses, and then they're no longer philosophy, right? So natural philosophy, that used to be a thing, we now call that physics and mathematics. And I think with AI, there are lots of questions that we still don't even really know how to ask yet. And philosophy is great for thinking about those kinds of questions. So yeah, philosophy of AI is a fascinating topic.
What's the strongest belief that you had which turned out to be wrong?
The strongest belief I had that turned out to be wrong is that I really underestimated how important scale is in artificial intelligence. I think this is really one of the things that OpenAI has excelled at, is that if you throw an order of magnitude more compute and data at AI systems, then they just become much, much better. And if you keep that scaling up, you have these scaling laws that we know about now. I really underestimated this. And for a long time, I was just saying like, oh yeah, look at these silly OpenAI researchers. They're just scaling things. They're not inventing new algorithms. That's not cool. And I was very, very wrong.
I'm going to apologize in advance for this one, okay? I'm sorry, I'm asking it anyway. What do you think the timeline is for superintelligence?
So despite like Nick Bostrom's book, I still think that superintelligence is actually very ill-defined. In many ways, we have already achieved superintelligence. Right? So in the 50s, we achieved mathematical superintelligence. So computers in the 50s were already better at calculating stuff than humans. So I don't think that really is a well-formed question. If you're asking about AGI, right? So and I think AGI itself, a lot of people, and this is a mistake I made where I thought AGI kind of meant artificial consciousness or something like that, which also doesn't really have a meaning. But if you look at how OpenAI and Anthropic and these places define AGI, it's as systems achieving capabilities that allow them to effectively do the work of humans for the majority of economically valuable human tasks, then we're not that far away from it. And so I think in the next like 5 to 10 years, that sort of economic displacement is likely to happen.
What's the most painful lesson that you've learned that you're also pleased to have gone through?
I think when I was young, I maybe put ambition before people sometimes. So I learned this the hard way, I think, where I just didn't have enough empathy for the people I worked with. As I grew older and more mature, I realized more and more just that it's really all about people and working with fantastic people and doing cool things together and changing the world together. So I'm very happy to have learned that lesson because that makes me much better at my job right now.
Final one. 10 years' time, if all the stars align, where's Contextual then?
So if all the stars align, then OpenAI and Anthropic and all of these places, they had this great first generation technology. So they're kind of like the Lycos and Alta Vista of search engines. And the technology we have is more like PageRank. And that would make us the Google of language models with the right technology at the right time and with the right execution. So that's what I would hope for.
Douwe, I've absolutely loved doing this. I can't thank you enough for putting up with my wayward, blunt, sometimes very naive questions. I can't thank you enough for letting me invest in you, and I really appreciate the time today, my friend.
Thanks for having me.